Hey everyone, so my name is Vuk, or Vukasin since I'm in Serbia. I'm the founder of Web3Mine, and today I'm going to talk about how we think about decentralizing the cloud, which in the Web3 context means how do we think about aligning particular resource providers, which can be storage or compute, and ultimately executing a particular workload. So the reason why we are working on this is the fact that we ultimately think the internet is broken today. And the reason for that is that, in a way, we are not controlling our digital lives. Most of the data that we store, most of the data that we generate is automatically being gifted to a particular set of organizations, and we really don't have much control over that. So we have no clue where our data resides, so basically we don't know which server, where, which redundancy, and so on. Then we have no idea on how decisions are made for us. So if you go to your Instagram feed, you're just going to see a bunch of people. But you have no clue how Instagram actually decided to show you that particular feed. And what that means is that basically in a way, like your digital identity is controlled by how algorithms are thinking about you. And guess what? Most of those algorithms are not really written by people that you should trust, rather are built by organizations that, as a reason why they exist, are for-profit organizations. And we're all fine with that, and in a way, like that's also expected from them, and they're not really evil people, because ultimately organizations need to somehow survive. But the issue is that the fact that we don't have transparency over that, and that those organizations are the ones that control most of the data that we are generating today. Now, yeah, ultimately, for-profit organizations are making all the decisions related to our digital identities. We have tried to tackle this, like a bunch of stuff on GDPR, a bunch of discussions in Congress, but ultimately, like all of these are kind of like trying to tackle something that is a fundamental core infrastructure problem as more of a social problem, which is not the best way of approaching it. So ultimately, the infrastructure is broken. And the reason for that is that everything is centered around legal entities, not users. So like if you store a particular file, that file is automatically gifted to a particular legal entity. You as a user are not retaining any rights on that file. In fact, like you're just checkboxing like a bunch of stuff before you sign up for those services. Now, the reason why that is the case today is not, again, because those organizations are evil or whatsoever. The reason for that is that in the 70s, the way that we designed like all the paradigms that we're working with today were mainly meant as a way for us to have something that was relatively performant. So the way it worked is that you had to figure out a way to retrieve a particular file. And it made sense that you have a big machine on one side that was the server, and you had like users trying to retrieve files from that big machine. That's just because it was more practical. But ultimately, that client-server model stuck, and today we're still using that, even though there is no reason for us to be using that. So because of that, of course, location addressing is by default. So like basically, whenever you're trying to retrieve a particular piece of data, what you're doing is you're looking for the location of that piece of data. You're really not asking for the data. You're just asking for the location. And of course, we have a bunch of abstractions that are helping that on the DevTool side to actually try to like manage the data well, and like we have a bunch of work that was done there, but ultimately you're asking for the location. And the issue with the location is that the location at the end of the day is going to be a server, and the server needs to be owned by someone. And that usually is a legal entity that needs to be incorporated in a particular jurisdiction, and basically needs to be controlled by a particular entity, board, shareholders, and so on. And again, is for profit. So after that, because of the way that like we designed the internet, all apps were kind of built to be location addressed. So like everything that is built today is by default location addressed. And the worst thing of all is that all dev tools that were actually built on that server client model are location addressed, meaning that like if you want to build anything today, you need to like do it in a location addressing like paradigm. Now, what does this particularly mean for each of us here? It really means that by default, all our data is not really ours. So ultimately, it cannot be ours. And the reason for that is that the infrastructure is broken. So what we need to do is we need to rebuild the infrastructure, which is a big thing, since we were using something from the 70s, and a bunch of work was done like with a particular mindset around like location addressing. Now we need to rebuild everything from scratch. So, and all of that is just because of the wrong paradigm. So if you go a bit deeper into like how that paradigm is wrong, ultimately, again, because we are referencing data by location, one single entity is dominating a particular use case. So is it really natural that we have one company tackling one particular use case? Why don't we have like more Facebooks? Like, it's one company, one ownership structure, and a particular shareholder group that just cares about the profits, and we are fine with that. No one here is using an alternative to Facebook. We are all using Facebook, and we are also calling those use cases by the name of the company, which is wrong, but we are just used to that. If you just go to Google, you're just going to say, I'm going to Google something. Why is search dominated by one particular entity with a particular set of shareholders in a particular jurisdiction? That should not be natural. And all of that is just because this centralized infrastructure is owned by one particular set of entities, and those are all the cloud providers, which is the reason why we are trying to disrupt that. Now, ultimately, what I mean all the time by like location addressing is that when you go to the URL in your browser, you're always going to have a particular location, and that is something that today, most of the time, is kind of hidden for you. Like Safari is just showing you like the main domain. Like they don't even show you like the location of the file because like it doesn't matter anymore. So what we actually want is we want to go back to the roots and really understand what we need as humanity. So what we care about is the content, is not the location. So if we want to reference something, we want to reference that by the content. As well, what we care about is we care about having multiple organizations working on a particular use case. So like, we should have more Facebooks. Like, why do we have only one? And the reason for that, again, is the centralized nature of the infrastructure. Because if you have a decentralized infrastructure, you could imagine having multiple apps that are doing like your social media use case, and you're consuming the same data. But actually, that's not the case today because like someone has a monopoly on your data, and it's not letting anyone else access your data, which is the reason why only one Facebook exists. But if we had like a decentralized infrastructure as a common good, like more as a water or electricity, we would be able to actually have multiple apps consuming the same data that is owned and controlled by us. And then we could think about potential use cases where we are keeping that data private, we are encrypting it, we are allowing particular entities to see that data if they incentivize us. In a particular case, maybe we want to sell the data or whatever, but then we have rolling keys and so on. But that's not the case today. So ultimately, we should ask a network for the content. And if we ask the network for the content, what we're going to get is we are going to get back the file from a particular node that can be like in this room, it can be like in this country, it can be in Europe or wherever. But it's not controlled by one particular entity. It's a common good that we can all access. And depending on whether the file is encrypted or not, you can see what's inside that file or not. So all of this is kind of cool, but it kind of seems like science fiction. But actually, we don't think we are that far away. So if you look today, like we have a bunch of progress that was done by like numerous organizations, like super reputable, super smart folks, and focused on a different set of problems. Now, in the case of Falcon, we have a network that is focused on storage. That network is great for archival today. I cannot say that it's great for retrieval as well. If you would want to do retrieval, you would probably use something that is not incentivized today, like IPFS. Then we have LivePeer, that is focused on encoding. Oh yeah, like I forgot to change the liper to encoding. But yeah, it's focused on encoding. Renderer is focused on rendering, and Chainlink is basically allowing you to just link a bunch of different networks and get information that you need in order to build smart contracts or particular logic that is living off-chain. So if you go a bit deeper into how these networks work, so like you have Falcon, which has like a group of storage providers. So those are organizations that are providing storage to an open network. Of course, you can identify like those files on that network through content addressing. So like you have CIDs that you ask for, and you would get like more information about where your data resides. And I'm going to go into that a bit later. But the important part is that every 24 hours, there is a proof that is a formal proof that is generated by that particular storage provider, proving that that particular piece of data is stored on the network. This is done every 24 hours for every 32 gigabyte sector with a snark. And that is on chain forever. So you'll always know that your data is going to be there forever. In the case of like them committing, of course, and there is some like economics in the background as well. But ultimately, we all think about Falcon as something that might come, like, and like of course, like we all waited for the launch of Falcon for so long that ultimately today, like most of the folks don't even think that folks at Protocol Labs are doing much, but actually they are. So like if you look at these set of organizations, those are great organizations. You have CERN, you have Berkeley, you have Solana. The Internet Archive is basically archiving all the data that they are generating by archiving the internet every 24 hours on Falcon, which is like a stupid amount of data, like petabytes. Now, if you go a bit deeper into the details on how like a storage network works, and by the way, I'm talking about the storage piece because the storage is the core here, like because on the storage, we're going to store the data, and this is how like everything is going to be architected around that. So ultimately, the compute is going to come on top of the storage. So the reason why I'm diving a bit deeper into the storage piece is that everything else is kind of going to be similar. So ultimately, you're always going to store files in sectors. So like the sector term is used by the drive. So if you have a hard drive, you have sectors on the drive. So like it was a nice way of like fragmenting a particular storage provider by having like a bunch of sectors stored on that storage provider. So sectors can be empty. So if sectors are empty, that means that the storage provider is storing just zeros and is generating a snark on top of those zeros, and he's, in a way, committing capacity. So that storage provider is basically just storing zeros. But you know that there is like a capacity that you can use as a storage client on that particular storage provider, which can be like in a particular jurisdiction or so on. Now, the way that you write to that sector is basically you do a snap. The snap is also like a snark, and you're doing some cryptography, and basically you're replacing the zeros with a bunch of data. So like you're just taking a big blob of 32 gigabytes, and you're just snapping that into an empty sector. Ultimately, one sector can contain multiple files. So you have a bunch of files, and you have the sector. So if you want to retrieve a particular file, you will ask that storage provider whether that storage provider has like a particular CID, which is the hash. You will provide the hash. The storage provider is going to tell you, yes, this CID is in this particular sector. If you want to read it, you need to get the entire sector. Now, this is as well why I'm saying Falcon is great for archival right now, not for retrieval yet. But ultimately, with the tech maturing, it's going to get better and better. Because you are transferring 32 gigabytes of data just to retrieve maybe a couple of megabytes of a file. So ultimately, like all of this is off-chain state, because like you're storing something off-chain, there is a proof that that particular piece of data is off-chain, but ultimately, it is off-chain. It's not something that you can read right away, nor you have like knowledge on whether that particular state is on-chain in that particular time. Of course, that is very different from like chain state, where you're basically just storing the same state over a group of providers. yeah, in the case of Ethereum, miners, however we want to call them. But basically, you're not storing like the same piece of data on every provider. You're storing one sector in one single storage provider. Now, what we do actually is we just connect all these networks, because like all of those networks right now are completely independent, like completely running on a different set of storage providers, compute providers, which is a big issue, right? Because ultimately, at the end of the day, if you want to consume a particular piece of data, like you need that to be at least in the same local network. You cannot be retrieving data like from all around the globe, which is not something that is kind of natural for us in the context of crypto. Like we're usually focused on like just chain state, and we don't care where people are. But ultimately, when you're moving a lot of data back and forth, you really care where the data is, because you are limited by the bandwidth that you have across the network. So the way it works is that we basically use liquid staking to incentivize a particular group of compute providers or storage providers to store a particular piece of data or to do a particular thing. So like if we could say, we are going to allow you to use this liquidity that we have only if you run also compute like infrastructure in the same data center. And ultimately, you'll have compute providers and storage providers that are kind of having some overlap, but you'll also have situations where you have a very specialized compute provider if the compute job that that compute provider needs to do is a very like high compute intensity workload. So for example, if you're doing rendering or encoding, that doesn't make sense to potentially be done in the data center where the data resides, but you want it to be somewhere close. You want a couple of milliseconds of latency. So in the case of compute providers, you can imagine of those folks basically as folks that are doing a lot of encoding, rendering, so have a big GPU farms, and so on. And the way that we would have the communication is by having like a bunch of like storage providers that are close to a particular set of compute providers. And you want a lot of bandwidth to be available between those two. The compute providers are more like Ethereum miners, where you have a bunch of people that have like a bunch of GPUs. Why this is important is because we want to commodize the compute resource. So like Ethereum miners and in general GPU mining really commodized the GPU resource as a thing. So like if you look at the profitability that Ethereum miners had, it was always close to like zero margins, which is what we want. We want the compute to have the cost as it would be like energy plus the OpEx that it takes to actually maintain a particular set of hardware, plus some amortization of the CapEx that was invested, which is, by the way, not the case with cloud providers. Cloud providers are taking 20, 30x margins, which is a big issue by itself, and I'm not going to get deeper into that. Well, storage providers are basically folks that are just storing a bunch of data. In order to store and archive a bunch of data, they need to be super efficient on how they store that data, and usually rack space is super expensive. So you can see a bunch of storage providers having like very dense setups. So they have like a bunch of hard drives in a data center, and like they have super lean infrastructure, and they're just basically petabytes of data like in one like rack. So yeah, ultimately at the end of the day, what you're going to have, like we are going to have like those compute providers and storage providers somehow like talk to each other. Right now, the main objective that we have is just basically having the same workloads run on a overlap of compute and storage providers, because otherwise the compute jobs are not going to be able to consume the storage. And that's the first step. Again, like if you look at how long it took for the location addressed internet to evolve, this is going to take at least 1/3 of that. And if that's 1/3, that's probably a decade. So we want to be just aligning everyone and allowing folks to actually run compute workloads, where in the future you'll be able to execute maybe the encoding of a video and then have some decentralized filter that basically allows you just to remove like the background or do something else on a stream that you're basically owning without having anything to do with centralized providers. And for a fraction of the cost, like probably 1/20th. So yeah, I think this is all I had. Yeah, like I'm going a bit deeper here into the fact that we're L2, but this doesn't really matter for this audience. So thank you so much. It was great being here and especially taking the last slot. So yeah, just grab me for a beer or something if you're interested in this.
If we have any questions for Vukoje, feel free to raise your hand. Yes, over there, in the back. Do we,
So you mentioned basically that you're using LSD derivatives to secure the network. Does it make sense to maybe use staking of Filecoin? You know, because like LSD obviously kind of gives you a derivative you can trade or whatever. So don't you kind of lose security because of that?
So let me try to reframe and see whether I understood the question. So you were saying that we have LSDs. So instead of having LSDs, like, would it make sense to use the native staking? Was that the question? Yeah, there is no native staking. Like, that's also something that probably I should have covered. We had to invent staking ourselves. So the way that the Filecoin economy works is that in order to provide storage, you need to also have a bunch of liquidity that you put as collateral. So like if that particular piece of data goes offline, the storage provider is getting slashed. So they are losing the tokens. So ultimately, the way that Filecoin was architected is that with more storage joining the network, more liquidity is going to get locked, and that's kind of how it works. So the way we approached it is we were like, okay, so this is a nice way for us to actually have leverage and make sure that the storage providers that are using our liquidity are actually doing what we think is right for the ecosystem as a whole. And on the other side, we have stakers that trust us that we're going to make great decisions for the ecosystem, and this is why they are staking into our pool. At the same time, we need to make sure that those storage providers are super efficient, and if they're efficient, we are able to like pass back most of the rewards that are generated by the storage back to the stakers. So ultimately, there is no staking. All the block rewards go to the storage providers, but the liquidity that you need to lock is super high, and ultimately, you need to like provide that utility as well, which is storage. But the liquidity is much more scarce. So like if you have one rack full of drives, which is probably around, yeah, it's around 9 petabytes. If you store 9 petabytes of data, like you would need to have probably $50 million of liquidity that you need to lock in that rack.
Does that answer your question? Do we have any more questions? Yes, over there.
Okay, so I was wondering, like, basically in a centralized world, when you like, let's say you have a bigger image, you put it on, let's say, S3 bucket, then you have a CloudFront that edges that, and then you basically have like a retrieval time that's minimal. So I was wondering, like, when we are looking at decentralized storage, what's the user experience at the side of fetching things, basically?
Yeah, that's a great question. So ultimately, if I understood something in the past, I don't know, 3 years at this point, working in decentralized storage, is that even all the things that we take as granted, that we have from the cloud, were actually slowly built, and you have so many abstractions that you're not even aware of. So like even AWS is not really building everything themselves. So they have, first they have like some kind of RAID on the hardware level. Usually that's done by Seagate or someone like that. Then you have a bunch of redundancy. So like they're gonna have, if you take like the cheapest one, they're gonna have like redundancy too. So they are gonna keep one particular sector, so a particular piece of data in 2 locations. Then you have like geo-redundancy, and then slowly they're just increasing the amount of redundancy. And that's just to store something. If you would wanna retrieve something in the context of Web3, you're just going to do that through IPFS. But even there, you need to have a set of nodes that need to be super fast. And you'll probably use something like Web3 storage, NFT storage, which is basically a centralized provider of that particular file that has a particular incentive to provide you a CID back super fast. And slowly, we are going towards a model where even the providers of that retrieval layer are going to be incentivized to give you back something super fast. And you have initiatives like Saturn Network that are basically trying to do that. But ultimately, the way it works is that on one side, you have Filecoin, which is just for archival. You're not going to even touch that. Oops. Yeah. You're not even going to touch that. And then you have IPFS. And on the IPFS side, you're going to have a bunch of tooling that will give you back the file super fast. And usually, that is going to be on a CDN or something like that.
Can you get the microphone, please? We have time for one more quick question before we move for the conference closing.
Does anybody else want to ask? So that sounds a bit centralized, at least in the moment. I mean, like we're having this decentralized part where it's archived, but then we actually have a centralized part that's caching that side and offering you to get it back.
Depends. Depends on how you get back the information on which node your data is. So you're going to say, I need this CID, and you'll have like a set of indexers that know like on which storage, archival providers, and retrieval providers your particular file is. And you're going to get like the list of providers, and you can decide where to retrieve it. And all of that logic can just sit on your client. And those indexers can be like super decentralized. So it's just about like decoupling the responsibility there, and also relying on the tech that we have built. CDNs are great. Like there is so much work that was invested in CDNs. We should not try not to use CDNs, but we should try to control like which CDNs we are using and basically treating them like as infrastructure providers and not as someone that can own our data.
Okay, thanks.
And with that being said, it's my honor and a little bit sadness to say that this was the last talk of ETH Belgrade.
Instructor.